So how many of you know what a Hyperloop is or how it works? That's actually not bad. Usually,
two different questions.
It was three, right. So I'll cover both of those things.
Yes.
And there were 3 employees from Hyperloop, so those don't count. Anyway, so we didn't come very far. We're just about a 3-minute Uber ride away in downtown LA. Anyway, so the capacity issue, which we've touched on already today, it's real. It's only going to get worse. 2 million flights won't even be able to fly by 2035 in Europe. And Asia, which has built some of the largest airports, most of them are already at capacity. In the Middle East, doubling in passenger demand over the next 25 years, or 20 years. So that means it's bad for the airlines, it's bad for passengers, and it's bad for local economies that depend on the money flows that come in and out of airports. So how does that relate to Hyperloop? That's the problem. Our solution is adaptable. I mean, many people talk about Hyperloop between cities, connecting, say Chicago, St. Louis, London, Manchester, LA to Vegas, in 20 minutes instead of 2 hours. That's the main use case. But as we've talked to countries and governments around the world, we've uncovered lots of different adaptations that make a lot of sense. One of which is an airport connector, both from airport to city and airport to airport. So just a quick primer on Hyperloop. This should play, right? No? Okay. How do we play the video? Here we go. There it is. Okay, so it's basically a pod and a tube. So the pod is a bit like a small jet with the wings shorn, no tail. It's in a pressurized or depressurized tube. We take most of the air out to eliminate aerodynamic friction. The motor, it's purely electric. It's a linear electric motor, basically like a rotary motor like you'd see in a power drill or almost any device that has a motor. We cut it in half, or imagine cutting it in half, and stretching it out along the bottom of the tube. So you have a stator, which is usually the stationary part of the motor, on the track, and then interacting with magnets that act as the rotor, moving across, propelling that pod at high speeds, up to say 600, 700 miles an hour through that tube. So there's no turbulence, very, very good energy efficiency per mile, no weather issues. It can be underground or above grade, so there's very little risk of interaction with the built environment, like trains have. And it'll all be wrapped up in autonomous software so the pods can talk to each other, the pods can talk to the control center. We understand where the pods are at any given time, and we can handle any kind of safety issues that may arise, as they inevitably do. That's the idea. And we are currently in talks with I'll show you some of the projects we have underway. But it's interesting what Blake was talking about bending that curve of travel. There's still a lot of work to do. So that's this is basically time on the bottom and distance on top. How far can you get in a certain given period of time? So that's a car. There's your high-speed rail, and this is your business aircraft. And you see, you have to get to the airport. That's the time elapsed in the bottom to go that fast. And you have to get to the high-speed rail station to go as fast as it can go. Cars, you can just drive out of your garage. So it starts at 0. So that's basically the best you can do, that dark line right now. You bring on new technologies like autonomous vehicles, which can go faster, be closer together because they're driven by robots. VTOL, which can start from your building if you live in a new building with a vertical takeoff landing pad on top. That's great, and that goes pretty fast immediately. And then there's your boom supersonic plane. You have to get to the airport again, but you can go boom straight up in the air. And that's so the curve now it becomes that. So the area to the left is us. This is where we go because we can go this fast right away. We accelerate about as fast as the plane does off the runway, but we can reach a much higher speed with a lot less energy. And we can go at different speeds. I mean, we're talking about 300 meters per second, but it's still a very interesting value proposition at 150. So it's great to think about linear infrastructure, and if the world were as A to B as it is, but it's not. We have a lot of points to point to, and we're designing a system that can go A to B, or B to J, or X to D. That's the idea. By breaking apart these trains that are often 15, 12 cars into individual pods that can leave every 2 minutes. You can get into a pod with a few friends or strangers and go exactly where you need to go, and we can send it at any time. It doesn't have to be full, and it doesn't have to wait for the entire train. It doesn't have to wait for someone else's timetable. Just another fancy slide animation, if you will. So this is us. We're 300 people, 250 downtown here, about 50 in Nevada. We're building real things now. This is our factory in North Las Vegas, where we do a lot of machining and tooling for this, which is DevLoop, which is our 500-meter test track. We basically built a sky that's 200,000 feet above the air, right here in Nevada, about 16 feet up. And we've been running tests since May. We had our Kitty Hawk moment where we had first liftoff on May 12th. Took this sled that's kind of more like a Formula One car, at about 111 kilometers an hour. And then we added an aero shell, also called XP1. I like that Boom called their prototype the XP1 as well. We put that on top of the sled to test the aerodynamic effects inside the tube. Even though there's no air, there's still effects between the pod, the outer edge of the pod, and all the surface area inside the tube. It's not a clean tube. And we went even faster and farther. So the next step is to work with the government to build something that's 10, 20, 30 miles long, with 2 stations, multiple pods, and really prove that the operations can work now that we've proved the technology works. And you can see we're already underway in 6 different countries. So how does that work with airports? So there's 2, as I mentioned. There's between airports, and there's from the city to the airport, just like Jackie was talking about. What if you can get into a Hyperloop terminal and be at the airport airside, checked in, biometrically scanned, maybe scans your gate as you walk through the Hyperloop part of it in minutes. You'd be like a boss. You just get out and walk right onto the plane, first class style. And we're talking to some, and you can get rid of exactly. People think that's so expensive to build that, but by avoiding the cost of building all that landside infrastructure, the duty-free and Starbucks and Aunt Annie's pretzels, you don't need all that stuff. And we don't want it anyway. We just want to show up and arrive and be in our location as fast as possible. That's the idea. So you could pay for the Hyperloop infrastructure with the money you'd save avoiding the building. So there's benefits for both the branch and the hub. We looked across the world, did a little economic analysis, and to try to find which airport pairs this makes sense for. There's not a ton, but we don't need a ton to make a business out of it. Basically, what you want is a very maxed out airport that's a major hub that's within 40 to 60 miles of a underutilized regional airport, perhaps. In New York, you think about Stewart Airport that's in Westchester. In LA, it could be Burbank. This is kind of a tough environment to build in, though. But we looked around and found one here in Amsterdam. We talked about Schiphol earlier. There's a little airport that's not even open for commercial operations called Lelystad, about 50 kilometers away. It could be the 7th runway for Schiphol. And the people who live over there can check in to Schiphol there and be at the main airport in 4 minutes. Or KLM could send a lot of its domestic or short haul, medium haul air travel flights to Lelystad and free up more gates for more profitable long distance routes. And right now no one really does this trip yet, but it would become instantly induced demand if we did. And the government of the Netherlands has actually talked about it. Their government has just formed, so they're still getting their hands around the priorities that they want, but it's of interest to them, let's just say that. Another one is here in Colorado, here in the United States in Colorado. We just entered a feasibility study with the Colorado DOT to look at a much larger front range Hyperloop, basically from Fort Collins area, Greeley to Pueblo. But the area of focus for the first phase is the Greeley to Denver airport. And it would connect with the aerotropolis they're trying to build around the Denver airport. There's a tech sector, there's a logistics hub, there's an agricultural area, but there's this intermodal area just to the right of that big yellow circle. You can see the two Hyperloop tubes coming down, crossing this, this new light rail that they built, and this new tollway, the E470. Basically, you could move a lot more air freight in and then up and out of the Denver area without causing a lot of congestion on 25, which is already becoming a viciously congested freeway. You could also, it could be a commuter line from the fast-growing areas in northern Colorado to the Denver area. People can buy cheaper real estate and be home in minutes in Greeley and pay 25% of the mortgage of the housing price that they would in Denver. So that's basically the point. Is you know, the bottlenecks are getting to the airport, checking in, security, transfer. That could all be avoided, as Jackie was talking about, by checking in the city with a smaller footprint Hyperloop station that's leaving all the time. There's a conveyor belt, like the APM that the LAMP project is building, but extend it another 10 miles. And as we mentioned, that you can integrate the security process into the flow of passengers using big data, identifying people well in advance of getting there, and you can even have like a pre-check for the Hyperloop era. People who are frequent Hyperloopers can I hate that word actually can check in well in advance of being there. So that's it. I mean, we often think about like who were we competing with? We're competing with rail, high-speed rail, or with the airlines. It's actually not a competitive issue. I think there's as you've heard already today, there's so much demand across all the modes, freight and passengers, that we just need more options. And we think it's time for new options. There hasn't been a major new mode of transportation in 100 years. The growth in air miles, the air miles that are travelable is actually slowing down. And whenever that happens, you saw it in the 19th century with steamships, with rail, with cars. Whenever that happens, a new mode is always coming up to take its place in the growth curve. We think it's time. And even the airline industry agrees with us. There was a kind of a scenario planning analysis they did for what the future of the airline industry should look like out to 2035, and they said recommendation number 17 was to engage with novel transport providers, not just us, but drones and unmanned aircraft, because everyone wants seamless connections and connections between providers. So that's my presentation, and we faced a lot of skepticism, as I'm sure Blake does, but so did the Wright brothers, and they were proven wrong. So do I have time for any questions, or we'll do that? Okay. All right. Thank you very much.